The insights you're going to have, ladies and gentlemen, we just saw one speaker. Now there are going to be two speakers right here on the stage. What?
First up, we have Mr. Vijaykumar Shetty sir, who is a senior cloud consulting architect and a program manager at Google. Vijaykumar sir is a seasoned professional with over 18 years of experience in data analytics, cloud, and AI. Currently, a trusted advisor, senior cloud consulting architect, and program manager at Google. Sir specializes in guiding customers through their digital transformation journeys. Sir's expertise lies in helping customers design, architect, migrate, and modernize their infrastructure, data warehouses, and applications on Google Cloud, enabling them to fully harness the power of cloud computing. Vijay sir is also a startups mentor in Google for Startups Accelerator GFSA program. Sir, it's truly an honor to have you here with us today.
And ladies and gentlemen, joining him on stage is going to be Mr. Pushkar sir, a software engineer at Google. Sir is a software engineer working on AlloyDB database at Google Cloud. His present area of expertise focuses on involving intersection of AI and databases. He has over 10 years of experience with working on database internals. Some of the topics he has currently worked on in the past are data storage formats, in-memory processing, paging, K8s operators for databases. So it's a true honor to have you here today, and the stage is all yours. Ladies and gentlemen, let us welcome them with a big, big round of applause.
Morning, Pune. Morning. Great. Okay, so let's connect the laptop first. Okay. Okay, morning. How are you everyone doing today? All good? Come on, I think I need some more voice from you. Okay, great. So thanks for a great introduction. Okay, there is a change. It's okay. Okay. Sorry, I think some technical glitches. Right. Thanks for the great introduction. So yeah, without further ado, maybe we'll give a quick start. Again, it's Vijay from Google Pune. How many of you have met before? Wow. Yeah, it's my home ground in that case. So Pushkar, quick intro.
Yeah, hi. I'm Pushkar Khadilkar. I work in the AlloyDB database team in Pune, and currently I'm focusing on sort of topics involving use of AI in databases, how we can make it more intelligent.
Got it. Thank you. So I think you got to know more about us. I just want to know more about you now, right? Why don't you take out your phones and just scan this QR code, okay, and then we'll just see like know more about you, isn't it? Okay, so everybody able to see the screen? There might be a back LED as well. You can take help of that, and make sure I think the whole check. Yeah, make sure we have this handy. I think you can keep it open in your Chrome from your phone. I think we'll go throughout the. This will be our medium today, okay? Right, so everybody, what are you seeing this right now? Person breaking the ice? That means we are, okay, okay, it's big here, that's good. Okay, so I see only 84 thumbs up. I think let's get some more thumbs up. That means everybody are on the screen, right? Okay, all set. How's the Josh? High, very, very high, or very, very, very high? Wow. Amazing, amazing. Yeah, I've got like 148 people logged in already. Okay. Right. Okay. From industry, startups, student, others. I'm keen on others as well, so let's just like what they are from basically, so that I can add it on my bar chart, isn't it? Oh, one is there. Raise of hand. Who is others? Two. Who are others? Raise a hand. No? Okay, I have 3, 4. I don't know. From academy background, maybe? Okay, that's fine. Good. I think it's like 50-50 percentage. So now as we are talking about cloud databases like AlloyDB, AI, right? So anybody heard AlloyDB? Heard about AlloyDB? Great. Right. So just a little bit people, but let's see what are we looking at right now? The cloud databases with or without Gen AI feature, isn't it? So, okay, so says like no knowledge, that's okay, a little bit, basic course. And yes, 18 people like understanding, a strong understanding and have need more. Even I lie over here. How about you, Pushkar? Where do you lie? Already know everything? No. Okay, so yeah, I think we got one over here so that they can help us out if in case any questions or something. Great. Okay, so what are the various cloud databases you have used so far, right? It's a free text. Maybe you can just put it across. It can be relational or document DB or anything. Okay, 100. Okay, that's good. Okay, Postgre, BigQuery, yeah. And we're talking about AlloyDB. Somebody has few hands on AlloyDB. Okay. Great. Okay, I think I'm talking about the databases, right? So it can be SQL. I think that's the first thing, and then we have NoSQL, relational cloud SQL. I see on the corner, one of the corner, Spanner, Cloud SQL, Firebase, Oracle, AlloyDB is also there, right? Fantastic. I think that's the reason what we wanted to talk more about AlloyDB. Said like what exactly it's there, where to use, when to use, isn't it? So that's good. I think it's a great databases where you have used so far. Okay. So let's jump into the slides. It's asking me to jump into the slides as well. Okay. So today's GAN, right? It's not a GAN, but still wanted to have a put on that. So we'll see like what are the different cloud databases we have offered by Google, and we got AlloyDB. And what are the AlloyDB AI innovations? And then we have got some problem statement which we use it for on real, real-time basis, right? So let's see some problem statements and how can we solve with the help of AlloyDB AI features. And a few demos, interesting demos. So how many would like to see console live? Google Cloud Console? How many of you would like to see live? Wow. I know, that's why you all are here. Okay, so without further ado, let's get into it. So, these are a platform where we have different types of databases for different types of users, right? So we start with in-memory, right? We got Redis, Memcache, memory store, right? So where we require in-memory cache required to do all your transactions. Now next, relational. So that's favorite for everyone, right? From how many years you're using databases? So what's the oldest database have anybody used till now with the raise of hand? Oracle? Okay. So that means it's of, what do you say, we are pretty old, right? Teradata? Teradata? Okay, good, good. I think that's still there. And now it's all like cloud databases coming in. So yeah, relational, right? We have got Oracle DB, which is able to put your infra on Google Cloud, right? It has a lot of Exadata and autonomous DB features for that, okay? And then Cloud SQL. How many of you use Cloud SQL? Fantastic. So what are different type of versions we can use? It's on a Google Cloud, managed Cloud SQL, okay? Where you can use Postgre, MySQL, SQL Server for analytics purpose or transaction purpose? What purpose we are using relational databases? Transactions, right? So all these relational are mostly used for transactional, right? And then we go on AlloyDB. I think we'll take a place for that. And Spanner, have anybody used Spanner? I saw a Spanner over here. It's a low latency relational database, right? So where you can, it's pretty huge, where you'd like to have multi-regional latencies and everything you want to use for that purpose, okay? And big table is a key value pair, right? So where, for example, what happens when you are putting your items on a Flipkart's cart or any of the apps, right? So it has to, for example, you and your wife is using the same account, right? So whatever cart you are adding, it has to instantly get into your wife, the same account which is your wife or your kids are using it. So that's the low latency what we need. So big table helps to get that things done on a real-time basis, right? And then Firestore, yeah, it's again a document database. We have analytics, BigQuery. So how many of you using BigQuery? Yeah, okay, yeah, that's really good. So that's a petabyte scale enterprise data warehouse, right? So I think these were databases, but now it requires state-of-art models being added to it. So as it requires a power to be powered by the AI, right? So like natural language SQL, right? Where you would like to, because I'm from a business background, I don't know how to write SQL, right? With the natural language, it should be able to help me out with the, what do you say? The query to be done, and then vector search, and then AI model thing. We're gonna deep dive that later. So which has a good ecosystem integration with MCP, Vertex AI, and LangChain if you would like to use some open sources as well, right? So now we're gonna do a deep dive of AlloyDB, right? It's Postgre compatible, right? It's a managed Postgre, okay? So that's the AlloyDB what we're gonna do, which can run anywhere. It can run on the cloud, on premises, on your laptop, but it has different flavors to it, right? First thing is it's 100% Postgre SQL compatible, right? So it's a managed SQL, right? And then it's gonna be a 2x better price compared to your on-prem databases, okay? And then it has a huge capacity to what? Vertically scale up to 2,000 plus vCPUs and vertically scale up to 128 vCPUs, right? And it is again a pay-as-you-go because we are in a cloud model. Whenever we require a storage, you just pay what amount you have, okay? And then 99.99 SLA availability, and then we'd have a lot of security features inbuilt and also embed with all AI ML features into it, right? Because that's the need of the day, right? And also, I was talking about on-premises. You want to run your AlloyDB on your own laptop or on your own data center, right? Where you have certain amount of reasons why we don't need to get into public, right? So AlloyDB Omni is a feature, right? Maybe you can explore it more, where you can run AlloyDB package, right? So to run on your system so that you can get features of AlloyDB, right? And then we talk about AlloyDB AI a lot. How can we supercharge the data with AI, right? And then, yes, I think this was one of the thing when we discussed, right? So OLTP, OLAP, this AlloyDB have special features. It can help not only to the operational or transactional data, also it can power your analytics workloads as well, right? So it's both because of its columnar engine, right? It gives the capacity of having structured, unstructured data accordingly, okay? And then it has like 100 times the faster speed of the analytical queries. And then also when it comes to AI, right? So we got like a lot of features what we're going to discuss today about AI, AlloyDB, like AI query engine, and then AI natural engine, vector search, and so on, right? And again, it's all been powered by state of art, the models, the GLLMs, what we have in a background, like Gemini, right? So how many of you use Gemini on day-to-day basis? Okay, so anybody explored Gemini 2.5? 2.5? Okay, so anything new you are seeing in 2.5? Anything new? Because it's all related. I'm not talking about other than the AlloyDB, but yeah, it's all related. I think the best part what we have seen here is if you have explored, there is a thinking option, right? Gemini 2.5 is breaking your AI black box, right? It's giving you a step-by-step process how Gemini is working in the background, right? So that's the one what I was talking about. And yes, what are the AI innovations with respect to AlloyDB, right? We're going to do a deep dive. Pushkar will help us out do a deep dive. But yeah, I think the one place is Google Agent Space, right? So anybody using Agent Space? Perfect. Okay, so anything, can you just tell about our Agent Space? Loudly. Some mics, please. Mic. There, the back. Yeah. Please. No mic? सर ऑन कर दो सर वहाँ पे जो दिया है बाप रे सबको भागना पड़ेगा अभी It's not working? That's okay. Interest of time, we'll go ahead, right? So that's an environment or a place where you can have different types of agentic AI framework to be built. You can build your own agents or use the existing agents which has been built to to get a step up for your own use case, right? You get a jump start for using that. So that's a place where we can an environment where we have, and also it requires some tools, databases from the external world. So AlloyDB has a capability to push the data, and where you can use it, the AlloyDB structured data to get the data from the agent space, right? Where you can read that data, where you can process the data, right? With advanced reasoning capability, right? And then natural language, I just mentioned about the natural language. We're going to do a deep dive. So with the help of natural language, where we're going to get that. Optimize SQL and vector search. That's again interesting, where we're going to span the vector search and get you the results depending upon the filters or joins, what we're going to give it, right? And at last, AI query engine, which is like a mix up of a SQL as well as the natural language, right? So with this, I'd just like to hand over to Pushkar. I think that you want to do this?
I think this is
Yeah.
Thanks, Vijay. So we'll do a deep dive on some of the AlloyDB AI innovations, and we'll also see them used in a demo. Okay, so starting with vector search. So vector search is sort of the bread butter for doing fast semantic search in database. So the idea is that you can convert your unstructured data like images, videos, or text into a vector representation, which is essentially an array of floating point numbers, and that is called as vector embedding. What this embedding gives us is that it allows us to do semantic comparison. So just like we do like some integer column equal to 5, which is a search for that value, we can do semantic search using vector embeddings, where you can the embedding embeds the meaning of the unstructured data, and we can then compare two unstructured data items. Like you can compare your query string with some blog item by converting both of them into vector embedding and then doing a vector search. And like you have normal B-tree indexes, we also have vector indexes to accelerate this search. So AlloyDB has a vector index called scann, in addition to HNSW, which is an open source index. So scann is based on Google's search technology, which is used in other products like search, the YouTube search bar. Most of the search products will use scann. So the same technology is also available in AlloyDB. Going forward. Yeah, so this is an example of how it looks like. So in this example, we have a few text items like teddy bear, some action figure, so some an online retail shop, some of their products. All of them are converted into their vector representations. And when we search for a query like recommend soft toys, that query will also have an embedding, and we can compare that embedding with the items already in our table, and whichever ones are near are sort of what are returned. So that is the vector search that will give us semantic similarity search. Another new feature which we have announced recently in preview is AlloyDB AI query engine. So the idea here is that, like, for vector search, we pre-process a lot of items, we generate embeddings, store them, and that gives us a fast search. The idea here is that instead of doing that, you can sort of directly use natural language within your queries. Internally, we will use LLMs like Gemini to understand that query. So here is an example shown here where there's a select query and a where clause predicate is using an operator called ai.if, and if you see the conditions, it's not a relational condition, it's searching for reviews which are positive and are for well-known brands. So the advantage of this is, like, one is flexibility and simplicity. You can write your parts of your queries in natural language. You can ask for something more complex which database would not normally support, like database would not normally know what's a positive review. And you can rely on Gemini's real world knowledge. For example, like database may not store what are the popular brands, right? But Gemini will know that. So sort of you can embed world knowledge into your queries, although it may not be present in your database. Yeah, you can use this in where clause, joins, anywhere flexibly, and we do sort of a lot of optimizations to make this fast and make it widely applicable anywhere in the query. So that's the second thing. So essentially, whatever you can get it from a prompt in Gemini, you can embed that as a part of your query and get that executed right from the databases without writing additional application code. The next one is another step further to say you can also have queries themselves, like you are not comfortable, you may have some users which are not comfortable with SQL queries. You can directly interact with database using natural language. So you ask questions in natural language, and we have this natural language feature which understands the meaning of your query, converts that into appropriate SQL, executes the query and gives you result. We have done additional work to make it secure so that we can control which users have access to which data and make it more accurate. I mean, compared to the standard text to SQL methods, we have features which make sure it understands the context of your data and the overall query is generated more accurately. We'll see this through a demo of how exactly it generates queries like this. So yeah, we'll take one problem statement and show how these AI features make it very easy to build applications which are not possible with some legacy databases which don't have these features. So the problem statement is, let's say you have a retail store where users search for products, buy products, and you want to give sort of easier to use experience using natural languages or chatbot. So some of the problems that are there if you don't have some of these AI features is one is that searches are typically limited by what your database already provides or require a lot of manual work where you tag manually maybe products description to say this product is an electronic product, this product is manufactured locally and so on. So that requires a lot of manual effort and it can't go beyond what you have already done tagging for or whatever the custom implementation that you have done. The second is that it also doesn't take into account easily the user's preferences, like someone wants something vegan or no artificial flavors and so on. The third is that if we try to build chatbots on it, if some of these features are not there, then chatbots are sort of not really understanding your queries. They are programmed to answer certain specific questions, and for other questions, they essentially fall back to another method. So these are the problems, and we'll show how through a demo on how we can build this more seamlessly using AlloyDB. So in this demo, we will use sort of two solutions that we shown here. One is the vector search and one is the natural language to SQL conversion. Okay. So this is the high level demo architecture. I think we'll directly see demo. This is just to explain how it's working in the background. So we have an online shop. So there's a website of that shop where user is purchasing products. There are two interfaces. One is the sort of search box where they type some query. Other interface is chatbot. Behind the scenes, like we have an AlloyDB database. So queries, we can send semantic queries directly to AlloyDB and sort of again using the vector search and vector embedding. And we are using scan and index. Then to dynamically generate embedding for whatever you are typing, we are using model endpoint management, which is like dynamically going to Vertex AI, generating embedding for your new query, and then comparing it with the data item stored in the database. Then the other side is for chatbot part, we are using two tools. One is the AlloyDB AI natural language, which understands your query. It's sort of trained on your database schema. It's guided using query templates. So if you have some frequent queries, important queries, so you can provide some examples to database so that it's more accurate. And the second tool we are using is a tool called MCP Toolbox for databases to actually make updates to databases. So this is the overall architecture. I think we'll go to the demo video and see it in action. Okay, so the demo is based on a Kaggle dataset for skincare products. We have built this custom website where there is a user called Tabby. She is logged in. She's going to search for certain skincare products. She has certain preferences, like she prefers vegan product and her skin type is oily. So like user has already entered some of the details. And I will now start with the demo where, yeah, it's just showing like what are products there are already in the catalog, and we'll do a search and then sort of show how it filters the product based on user's query. So here we are searching for preventative aging, right? And if you see it showing creams and sort of skincare products related to preventative aging, and it's not a pure keyword search, because if you see, none of the products have the exact keywords preventative or aging. So it's like understanding the meaning of your query. And this is how we are showing like behind the scenes what is happening. So this environment is AlloyDB Studio. We have several tables like product description, product reviews. And this is the query that is answering the example there. So if you see here, the query came as a part of a vector search query. We dynamically generated embeddings for it. We compared with the products, and the list you see here is the exact ordered list that you see in the demo. So this is what query executed behind the scene for this use case. Now let's say we want to make it sort of adjust it to users' preferences, which were in this case vegan products and oily skin, right? So we have it in a demo where there's a button edit which applies users filters, users which are vegan and particular skin type, and dynamically the list is updated to understand those preferences. And what this is doing behind the scenes is like it's doing the semantic search like we shown, but in addition it's also doing adding the normal relational filters, which were like, is the product vegan or not. So you can combine relational filters and semantic search and get the combined output. Now we'll move on to chatbot part. So here the user is searching through chatbot for certain creams that they want, and here is the chatbot is using natural language to SQL, and here we can see the query generated. So query was, are there any products for symbol prim that fit my preferences, and looking for creams. So it understood the context that symbol prim is a product name, cream is the product being searched for. It also auto applied. So this whole query was generated by natural language based on the query given here. We'll see an example of another query where let's say user is searching for a product that they ordered previously. So what skin tint they ordered previously. So it's looking for historical data. Just another example, and here we can see again for this it generated a different query where it understood now the product is skin tint and only showing the results for that. And then user is sort of going ahead and then ordering it. Chatbot can ask for confirmation. This will behind the scenes go through MCP toolbox, which will execute a sort of update query on the database to actually purchase the product. Yeah, so this is how you can build highly interactive applications which are responsive to users, natural language questions, and are flexible. You can combine all of these features together. I'll hand it over to Vijay for another demo.
Thank you. Thank you. Yeah. Okay. So yeah, thanks Pushkar. I think what all features we went through here is like AI query engine, vector search and natural language, right? So I think the one what we discussed today is about AI query engine. That we're gonna do it, okay? So now we're gonna get a feel to get into Google Cloud Console, okay, and then try to play with that actually, right? So this is how the AlloyDB clusters look like, okay? And we got a AlloyDB Studio like as all SQL editors, right? So we need to have a SQL editor where you can get your SQL fired and interact with the database, right? So right now, I've got a reviews table, right? So I know everybody would review and update over there. So it stores somewhere in their databases, right? I'm asking this one to, for example, select user reviews. You review text like pizza, okay? And a prompt, okay? So we may have a field like Europe, a field like a country in the database table, but it doesn't have a reviewer from an European country, right? And it's asking about a user country, which we are feeding it over there. But it's a query engine. It's like a mix of kind of a structured query language as well as what we are trying to do here, natural language, right? So, for example, let me run this one, okay, for you. So I'll just run. And I write it, if reviewer is from a Scandinavian country. What are the Scandinavian countries? Any guesses? Yes, so we got Sweden and Denmark, right? So we have a field like user country, but we never defined it saying, okay, what are the Scandinavian countries or any other countries, right? It again talks back to the LLM, right? And helps you to get the details. And because I may not know, like, because I need a lot of details, basically, right? So this is one example where I'm trying to fire a query, right? And I'll just fire a query again for the second one where I'm just trying to put a European country, right? So I think we may get more number of results right now. Okay, let's see. Wow. So we got like review ID, user ID, and then we have got countries, because even I've got like Scandinavian countries as well, along with Switzerland, Italy, wherever the reviews are come from the EU Council. Same way, I think this is one of the example. Now I just want to know more about where I need to do some joins, right? It takes some time, but yeah, should be okay. So what I'm trying to do, I'll just fire the query first, and then I'll explain what is this query about, right? So here, what we are trying to do, a restaurant with user reviews, right? And also where we need about the review, type of review is like, is it a positive, negative, or neutral? And then I'm putting a review about pizza as well as what? As a population more than 100K people in it, right? So if you see here, so there is a name, what I'm trying to do, name and the city. That's it we need. So name and city, New York. So these are the two things where it is having a positive reviews, okay? As well as the population which has more than 100K, and it's about positive reviews about pizza. So basically it's a combination of both SQL as well as the natural language into it, right? So where it requires a lot of times where we need to need difficult to put a where clause or where filter, right? At that point of time, we require these kind of things, right? So with this, I think that was a quick demo, and just want to come back to Menti again, everyone. So yeah, I think it should be on the same thing, right? Same Chrome, same browser if you are already on your phone, which you have started, right? If we have not done, again scan it, again you will get that back. Okay? So I think it should be somewhere like this. Okay, that's good. So we got people around. Okay, so I think just before we wrap the sessions, what are the new things we got to know from this session? Because I think everybody, we are spending time on weekends, you know, a lot of places where we need to spend time as well, right? But yeah, I think good that you have all come over here. Yes. So AlloyDB, yes, at the center of the screen. That means like, okay, everybody have went through it, right? So yes, remote config, okay, that was from my other colleague session. AI in databases, vector search, natural language. Yeah, I think we covered up all the things. Hybrid query, yeah, you can, I think it's a good one. So you gave a name like hybrid query, what we just did for AI query engine, isn't it? Yeah, AI query engine, okay. And databases. Okay, fantastic. I think that's good. And yeah, before we wrap up, I think just with you guys enjoyed the sessions today till now, and hopefully I think I'll enjoy it the rest as well, right? So, okay, thank you. And yeah, you have any questions, anything, you can leave a question back over here, and then we can reach out if you have any questions, right? That's good. So I'll just leave it open, okay, with this. Yeah, we'd like to thank you. Pushkar, would you like to add anything?
No, thank you for being here, understanding content, and we'll be around if you have questions later.
If you have any questions, what we're going to do is we'll be around, and maybe during the lunch and all, we'll have your questions answered in the tough time. Thank you and have a great day, and cheers.